Coal is dirty, nuclear is scary, solar and wind aren't always reliable, hydrothermal and hydroelectric aren't widely accessible, and will eventually deplete our oil reserves. Okay, yeah, this is hyperbole. But the bottom line is that we don't have a perfect energy source. But there might be hope. Around the world, people are working on fusion energy, which might be the safe, efficient, reliable, clean energy source that could save the planet. All right, that's a bit more hyperbole, but it would be world-changing. So, how close are we to fusion energy? This may come as a surprise to some, but fusion is not some futuristic sci-fi idea. It's real, it's happening, and you've seen it.
Fusion energy exists. Every time we go out in the day and look at the sun, we see a big ball of burning hydrogen gas. If you go out at night and look at the stars, those are also billions and billions, to quote Carl Sagan, of burning plasma engines, fusion engines.
We've always followed the stars for direction, but we need to learn to emulate them.
The twinkle of a star and the heat from our sun are byproducts of fusion. Fusion is the process of two light atoms, like hydrogen, being forced together due to immense heat and pressure to form a heavier atom, like helium. When this merger happens, energy is released, which creates heat and light. Fusion is the energy that makes life possible on our planet, and many think that fusion will power our cities of the future.
We're burning things, which has got to stop. We just literally set fire to things. That is really how we power cities at the moment. It's very inefficient, it's very dirty, and it's not doing our atmosphere any good.
And our atmosphere is one of the main reasons people are excited about fusion. Unlike fossil fuels, nuclear fusion doesn't release toxins and polluting greenhouse gases like carbon dioxide. The byproduct of fusion is helium, an inert, non-toxic gas. The fuel is made of two hydrogen atoms that can be pulled from our abundant supply of seawater, and yes, fusion does produce radioactive byproducts, but the half-life of that waste is much shorter than any fission reactor. It's for all these reasons and more that nuclear fusion is viewed by many to be the cleanest, greenest, and most viable alternative to fossil fuels that we humans have. In fact, one of the biggest advantages touted by fusion supporters is that power plants might be able to plug right into our existing electrical grid, meaning we won't have to reinvent the wheel when it comes to energy infrastructure.
Essentially, the basic premise of fusion is to take the sun, shining ball of hydrogen in the sky, and to bring it to Earth, and to use the heat it produces to generate steam, and use that steam to turn a turbine.
Now, of course, we can't just grab a star and transport it to Earth, but we can replicate the conditions of a star, and we have. We currently have the technology to heat up hydrogen atoms to well beyond the temperature of the sun, to a point where fusion can occur. We have the technology to keep that superheated plasma in place long enough for the fusion to actually happen. We know we can turn heat into electricity, and currently have the infrastructure to put that electricity onto the grid. So why can't I charge my phone with electricity made by fusion? Well, it all comes down to Q. In the world of fusion, Q represents energy gain. Basically, power plants of all kinds need electricity to produce, electricity. This is only worthwhile if you can make more electricity than you consume.
No one has done that yet. That isn't to say people haven't made fusion reactions happen, because they do, and they do more and more every year. And we have more and more knowledge of how this works every year. But that first step hasn't happened yet. More out than you put in.
It seems like right now, the marker for success is a reactor that produces 10 times more energy than we put in. That's the goal for ITER, the largest scale fusion experiment on the planet that's been in the works for decades.
ITER represents a collaboration of something like 30 nations on Earth to contribute to building a tokamak and demonstrating an energy gain, a capital Q of 10.
This is really exciting, and many think that the science is actually already proven out, meaning that when it turns on in 2025, ITER will meet or exceed its goal. But the experiment is only that, an experiment, to demonstrate that fusion can produce a net energy gain. As big and as expensive as ITER is, it will not power anyone's home. If it's successful, then a power station called DEMO will be built, aiming to put fusion electricity onto the grid somewhere between 2030 and 2050, or maybe even a little after that, which is one of the complaints about the world of fusion so far. It takes so long.
So one of the major issues with working in government projects is that they are notoriously bureaucratic. We're building parts all over the world. It is the perfect storm for a delayed project, an overfunded, over-budgeted, delayed project.
But government projects aren't the only way to achieve fusion. Private companies are also getting in on the world of fusion, and they're not waiting around for ITER to prove successful. For example, MIT, helped by Professor Hartwig, recently teamed up with a private company on a plan that they think could lead to an operational fusion power plant within the next 15 years. But it's not just money that's the key to fusion success, it's also awareness. The more vocal the public is about wanting fusion power plants, the more governments and investors might actually take notice.
As every politician knows, the public plays the only role in this. And I think this is sort of an important issue. You know, do people trust whoever is building this in a way that they will accept this as a part of their everyday life?
So for nuclear fusion to happen, it might take you. It might take you to read about it, to learn about it, talk about it, watch videos about it. There are fusion experiments currently being carried out all over the world, and the computer models have already proved that the science works. People want it, governments want it, private industry wants it, and the environment wants it. It just needs to be tested, built, made scalable, approved, and installed. So, how close are we to fusion energy?
You know, the world that we would have fusion energy is clearly a future world. It's 30, 50 years, you know, where it's a dominant form of energy if everything goes right.
Fusion is the only candidate we have. It's what the stars are doing. It's what the universe is telling us to do as the right way to create energy. It's not, do you think it's the right way or not? It's coming for sure.
Thanks for watching, everyone. If you want to know how close we are to resurrecting the mammoth, curing AIDS, or taking pictures of black holes, you can do that right here. And thanks again.